Hello again, Geometry B. Right, so what we're going to do today is we are going to continue what we were doing with trigonometry. Right? And today we're going to talk about how to find missing sides. Right, so just to kind of recap trig ratios so far. Right, the sine is the opposite side divided by the hypotenuse. Right, the cosine is the adjacent divided by the hypotenuse. And the tangent is the opposite divided by the adjacent sides. Right? These sides, like the way that you name them, depends on which angle you're looking at, right? So in that triangle that I have on the screen there, just the one up at the top, because there's two, you might notice that I have a little red arc in one corner, right? That's the angle that I'm naming them in relation to, right? So the one across from it, right, is the opposite side, right? The one that's kind of next to it, that's not the hypotenuse, is the adjacent side. The hypotenuse, you can always tell which one that is because it is across from the right angle, right? I know that throwing those three arrows in there probably doesn't make it seem very nice, right? But just remember that that's how we name them. Right? You also have the helpful little phrase, so katoa. And it's really good to say in a bunch of weird ways like so katoa, right? To help you remember which way they go, right? They tell you the sides in order of what's on the top of the fraction and what's on the bottom. You also have now learned that we can use the inverse trig functions like sine to the -1 there, right? Sometimes also called the arc sine, right? You can call it the arc cosine, the arc tangent, right? Or you just put that little -1 up there, right? Those are inverses that can help us find missing angle measures if we know about two of the sides. Right, so today we're going to look at how to find missing sides if you know one angle and one side. Right, so I'm going to kind of zoom in on this a wee bit there. Right, what we're going to do is we are going to take a look at this diagram that we've got here. Right, we've got this triangle. All I know about it is that I have a 25-degree angle here. I know that one of the sides is 18, and I know that one of the sides is x. That's what we're going to be looking for. So the tricky part here, right, is figuring out what to use, right? So what you should do first, and what I like to really do on these, is like to think about what do I know about this triangle? Like what sides do I know about? Right, so I'm going to look at that 25 degrees, right, because that's the one that we have to work off of. Right? What I'm looking at is I'm looking at this side that's opposite from it. Right? The other side that I'm looking at is this side that's adjacent to it. Right? This one down at the bottom here, right, that's the hypotenuse. It's across from the right angle, but we're not using it for this problem, right? It's not even something we're worried about. It's not something we know, and it's not something we're asked to find. So if I'm talking about the opposite and the adjacent sides, right, that means that I'm going to use the one that uses the opposite and adjacent, which in this case is the tangent. Right, so TOA, T-O-A, opposite adjacent goes with tangent. So the way that we're going to set these up, right, is that I know that the tangent of that 25-degree angle is going to be the opposite side divided by the adjacent side. So in this case, that means that the opposite side is x, the adjacent side is 18. Right? Honestly, after we get that part done, we don't really need the triangle anymore, right? Now it's just an algebra problem, like a lot of things that you've run into. Right? So one thing that we can do, right, there's a couple different ways we can kind of algebra our way out of this. Right? One way is that we can go ahead and we could consider this as tangent of 25 over 1, do like cross multiplying and stuff like that. Right? But sometimes that feels a little iffy. Right? So what I like to do instead is I like to think, all right, I want x by itself. Currently, x is being divided by 18, so I need to do the opposite of that. So I'm going to go ahead and multiply both sides by 18. Right? When I go ahead and do that, what's going to happen is that these 18s cancel on the right side. So we're left with just x. Right? Over on the right side, now what we've got is we have 18 times the tangent of 25 degrees. Right? So that seems all fine and dandy, right? But what the heck is 18 times the tangent of 25 degrees? So that's where you're going to use your calculator. All right, so what we're going to do is just type in 18 times the tangent of 25 degrees. Make sure that your calculator is in degree mode. Right? Hit enter. And what that's going to do is it's going to spit me out with a number. Right? In this case, it looks like 8. Let's just round it to 8.4. right? That's about equal to x. Right? I'm using that little squiggly equal sign because there are more decimal places that came after 8 point. Right? It's actually 8.393537,847, and I'm sure it keeps on going. So we use a little squiggly equal sign to say like, okay, I rounded this is about what it is. Right? But what that's telling us is that that side length is about 8.4. If I take a look back at the triangle that we're working off of, right, 8.4 seems like it could make sense there, right? It's not like completely out of left field. If that big side is 18, that smaller side could certainly be 8.4. Cool. So let's try another one out, right? On this one, again, we're taking a look at what we know. I know about this 70-degree angle. I know about this hypotenuse. Oops. And I also know about this adjacent side, right? So when we're working with the adjacent and the hypotenuse, right, so those are the things that we know we're talking about, adjacent, hypotenuse, right, that means that we are going to use the cosine, right? So again, what we're going to do is we know that the cosine of 70 degrees is going to be equal to this ratio that we can set up with those sides. It's the adjacent, 15, divided by the hypotenuse, x. Right? So what we can do here, right, and this one's going to have a few more steps than the last one, unfortunately. Right? And actually, with that in mind, let's scooch this down a little bit. It's like magic. Oh my gosh. So what we're going to be doing here is I want to get that x by itself. So what I'm going to need to do is I'm going to try and get it out of the bottom of that fraction. So the way that we get rid of the bottom of the fraction is we multiply. So if I multiply both sides by x, right, what's going to happen is that it's canceled out on the right, and it's now moved over there. So this is x times the cosine of 70 degrees, and it equals 15. Right? So that doesn't actually get us fully to a place where we can just find an answer, right? We still need the x by itself. But now that we have x times the cosine of 70 degrees, what I can do is I can now divide both sides by the cosine of 70 degrees. Right? So as I do that, right, it's going to cancel out on the left there. Right? Those are now gone. All I'm going to have is that x is equal to 15 divided by the cosine of 70 degrees. Right? So again, something I'm going to type into my calculator, 15 divided by cosine of 70, right, is going to give me about 43 point, let's call it 43.9. We're rounding it again a little bit. Right? So again, a good thing to be able to do is to go back and say like, all right, does 43.9 kind of make sense? Like, does that seem within reason? Yeah, 43.9, like basically 44, seems like it could be the length of that side. That tiny piece is 15. 44 doesn't sound completely out of left field, right? So this is where we're trying to get to. We're trying to find these missing side measures, right? The trigonometry piece is really just setting up the equation, right? And then we're using a little bit of algebra to move the x around until it's by itself. Let's try another couple of these out, right? On this one, it wants us to find the length of BC to the nearest tenth, right? Which is what we've been doing, right? We've been rounding it off to the tenth, right? So again, it's a matter of looking at the angle you're told, figuring out which sides you have, right? I have an opposite side, and I also have an adjacent side, right? So if I have opposite and adjacent, right, that means that I'm going to use the tangent. Now you can think of TOA, TOA. So again, on this one, that means that I'm going to take the tangent of that 65-degree angle, and that's equal to the opposite side divided by the adjacent side. Right? So you might notice that this is sort of similar to the last one we just did, right, where the x was on the bottom and it had like an extra step to it. Sorry. But we're going to use the same kind of methodology right here. Right? I'm going to multiply by x on both sides, and it's going to cancel out the bottom of that part. Oops. Somehow we switched to orange highlighted it. So now I've got x times the tangent of 65 degrees equals 12. After that, same as before, I just need to divide by the tangent of 65 degrees on both sides. And what's going to happen is that these tangents cancel each other out. We get just an x. And then this side looks really nice, right? 12 divided by the tangent of 65 degrees, right? And again, it's just something to plug into the calculator, right? Something that people used to have to do in the olden days, like when my mom was in school, they used to have to use these big tables to figure out these tangents. Like they had a table where it just told them tangent of 65 with a bunch of decimal places because the calculators couldn't do that. Right? But now we can just plug it in. If I do that math out, it's going to come out as about 5 point, because they want us to round it, it's about 5.6. Right? And again, what I want to do is make sure that that makes sense for the problem I'm working on, right? If I did this problem out and say I ended up with, like, oh, x is about 65, that doesn't look right on this triangle, right? You can't always trust the diagram, right? But it should be, sort of making sense, like sort of in the same neighborhood as some of the other numbers, right? If you have that big long side is 12, it makes sense in this case that the adjacent side there that we're looking for is about 5.6. Right. Let's try another couple out. Right. Same idea. We're just looking for the pieces that we know and working off of that. So we got this 42-degree angle over here on the left. What I know about is I know something about the hypotenuse. I know that I'm looking for it. And I know something about this adjacent side. So if I'm talking about adjacent and hypotenuse, that's telling me cosine. Oops. So the cosine of that 42-degree angle, I'm going to set up as the adjacent over the hypotenuse, right? So in this case, let's move that out of the way a little bit. That's going to be 8 divided by x. Again, same kind of pain in the butt steps that we had to do before. You multiply by x on both sides. That'll cancel those out on the right. You get x times the cosine of 42 degrees equals 8. If you divide both sides by the cosine of 42 degrees, then what we can do is we will end up with x is equal to 8 divided by, sorry, I'm running out of space there, cosine of 42 degrees. You plug that in a calculator and you see what it spits out. 8 times divided by the cosine of 42, as I'm typing that in real quick, gives me about 10.8. Right? And again, triangles are not drawn to scale. They even tell us that in the beginning of this problem here, right? You can't always trust the triangles, right? But you also don't want to get an answer that doesn't make any sense, right? Especially if you ended up with a negative answer, right? If I found out that x was about equal to negative 14.3, that doesn't really make sense because I can't have a negative distance, right? I should end up with something positive. I should end up with something that's not like 18 trillion and 5. You don't want something that's way out in left field. All right, same kind of idea here. Right? If you haven't tried one on your own yet, try this one out. Right? We've got 50. We've got an opposite side. We've got an adjacent side, right? Because this is the hypotenuse over there that we're not really using at all. Right? If I'm working with the opposite and the adjacent, I'm using the tangent. So the tangent of 50 degrees is the opposite over the adjacent. So I don't know if you notice what I'm noticing, right? But this is one of the easier ones where we don't have to do 17 steps, right? All I got to do here, multiply each side by 15 to get that x by itself, right? We're undoing the divided by 15 part. So 15 times the tangent of 50 degrees is equal to x, right? And something else you might notice is that I'm still using a regular old equal sign, right? I haven't had to round anything yet. That's still like an exact answer. Once I plug 15 times tangent of 50 into my calculator and have to round this off to about 17.9, then that's where I'm switching over, and now it's approximately that. All right. Whew. All right. Last couple here. All right. Again, if you haven't tried any yet, try these ones out on your own. Right? Give it a go. See if you know what you're doing. We got this 32 degrees here, right? And then this actually has two different parts to it. right? We're actually trying to solve for both of those missing sides. So for x, let's start with that one first. So that one I'm going to do like marking stuff up in red. So for x, we know about this adjacent side, and we know about this opposite side. Right? So that's what we're going to do, and then we're going to use the tangent. So the tangent of 32 degrees is going to be the opposite side divided by the adjacent side. So in this case, that's 24 divided by x. We do those fancy steps that we were doing earlier, right? We're going to multiply by x on both sides. Let's see if I can kind of squeeze that in. Actually, zoom in. We have the technology. If I multiply by x on both sides, cancels those. We get that x times the tangent of 32 degrees equals 24. And then if we divide by the tangent of 32 on both sides, then that will get us x all by itself. All right, I'm actually going to kind of spit this out over here just so we have room to do the other part. So what I'm going to have is that x is equal to 24 divided that by the tangent of 32. If I plug that in, 24 divided by tan 32, x is about 38.4 is what it's telling me. All right. And again, taking a look at the triangle, 38.4 doesn't seem like completely out there, right? 38.4 sounds like it could be the length of that bottom part of this triangle, right? The other part that we're going to work on, right, is y. And we're going to talk about how to find y. So y, in this case, is the hypotenuse, right? 24 is the opposite side. Right? You might notice we're using that same angle because it's the only one we know about. Right? So when I'm looking for y, I now got the opposite side and the hypotenuse. So thinking about SOHCAHTOA, that's telling me that I'm going to use the sine of 32 degrees. It's going to be the opposite over the hypotenuse. Right? Again, we got a couple steps that we need to take here. Right, so I'm going to multiply by y on both sides. Right. What that's going to do is that's going to cancel the y's out over on the right. I'm going to get y times the sine of 32 degrees equals 24. After that, all I need to do is get that y by itself. So we're going to divide by the sine of 32 on both sides. Right. Seeing what that gets us, y is going to be equal to exactly what we had just a second ago, 24 divided by the sine of 32. All that's left is to plug it in a calculator. 24 divided by the sine of 32 is 45 point, and we're rounding it a little bit, so 45.3-ish. Right, for that long side y. Right. And again, I'm going back and I'm taking a look at that triangle and saying, like, all right, does that sort of seem reasonable? Does it seem likely that that long hypotenuse could be about 45-ish if the other sides are 24 and 38.4? It's like, yeah, that doesn't seem completely out there. It seems pretty all right. So be sure to check back on Google Classroom for any additional resources and assignments you got to do. Please be sure to reach out to your teacher if you are having trouble with these, right? Trigonometry is something that's pretty cool. If it kind of clicks in your head, it can be not too bad. But if you're having trouble with it, we're here to help. Please reach out if you need to. All right. See you next time.